Okay, dear students, having completed the derivation for 5 marks, let us take some more problems to understand better how are we going to go for completion of square and then applying the formula of 1 by quadratic and 1 by root quadratic. So, continuing with the oh, continuing with exercise 7.4, where we are going to have 1 by quadratic, that is ax square plus forever, I think is okay. So we're discussing 1 by quadratic. So 1 by x square plus bx. What is this? After filling the ink also same. This is better. So x square plus bx plus c and 1 by, okay, with respect to x here. Then again root of ax square plus bx plus c. Okay, 1 by quadratic. Now let us try to recall all the results this side. Surely a is not equal to 0. Okay, now say this, the result which we have, integration of 1 by, see 1 by plus adding dx adding, then the denominator, because 1 need not be written, it's understood. Okay, so it is the first one. Let us say here we have got a square minus x square, it is 1 by 2a log of mod a plus x divided by a minus x plus c. Second formula, integral of 1 by x square minus a square is 1 by 2a log of mod x minus a divided by x plus a plus c. Third one, integral of 1 by a square minus x square, let us say under the root, it is sine inverse of x by a plus c. Fourth formula, integral of 1 by a square plus x square is 1 by a tan inverse of x by a plus c. Okay, right, plus c here. Fifth one, integral of 1 by which is pending now. Okay, fine, root of x square minus a square is equal to log of mod x plus root of x square minus a square plus c. Lastly, integral 1 by root of x square plus a square is equal to log of mod x plus root of x square plus a square plus c. Yeah, 1 by 2, yeah, here plus x minus 1, 6 minus a, fine. Yeah, all done. So all are 1 by quadratic. You can see 1 by quadratic here, here 1 by root quadratic, again 1 by quadratic, and I can see in all these cases the most important a is always positive. Okay, this a is different from this a. This is x square multiple. This I'm talking about constant in this formula. Okay, fine. Now let us take problem on this from the exercise. Now dear students, let's move on to this problems 1 by quadratic form from the exercise 7.4. I have given the same numbering as per the textbook. Now here you see, again don't try to see that. That's right, just see here. In this one thing analyze, see this, a square multiple is positive, x square multiple is negative, whereas here x square multiple is positive, a square multiple is negative, and here if you see both are positive. So depending on that we have to choose who is positive and who is negative. Same thing is happening in root also. a square multiple is positive, x square multiple is negative. Then x square multiple is positive, a square multiple is negative. And here both are positive. So what if both are negative? Then under the root negative is not defined, it's not a real number, that chance is not there. But here, if x square multiple is negative, a square multiple is also negative, I can take minus common. And as soon as I take minus common, it becomes this form. So I'll get minus of tan inverse of x by a into 1 by a plus c. Now you see this. First, my variable and constant should be square term, as you can see here. So first try to square this. Can't we rewrite this as dx by square root of 1 plus, in place of 4, 2 square again, so 2x the whole square. So you can see root is there. Okay, fine. Both constant and variable are squared. So without seeing the formula that side, I can just say, oh, integration of 1 divided by root is there, so root is there. Constant square plus variable square, constant square plus variable square, and the answer for this is log of mod x plus root of a square plus x square plus c. That's what we have got here. Whether at a square plus s square or x square plus a square, both are same. Now if I compare, in place of a square we have 1. So a square is 1. In place of x we have 2x. So substitute here, what will you get? Log of mod of x, in place of x 2x, plus root of a square is 1 plus x value is 2x the whole square plus c. Under integration, x multiple should be divided. X multiple is 2 here, that should be divided. So the answer will be half of log modulus of 2x plus root of 1 plus 2 square is 4 and then x square. So 1 plus 4x square plus c. Okay, I hope this is clear. Now come to this. This is already in square form. It is already in complete square form, but see carefully. This resembles which one? See carefully. 1 by root of, because what is that? Square of the variable plus constant also positive. So it is x square plus a square, which is nothing but log of mod of x plus root of x square plus a square plus c. So in place of x we have 2 minus x. In place of a square it is 1. Put here log of mod, in place of this x we have 2 minus x, then plus root of, again in place of x 2 minus x, then square plus a square is 1 plus c. Again under integration, x multiple should be divided. X multiple is minus, so divide by minus 1. Okay, now 1 by minus 1 is minus 1. So I'll have minus here 1 log of, this is one term, mod of 2 minus x plus root of 2 minus x the whole square plus 1 plus c. Now recall one property of log. What is k log m? It is log m power k. So in place of k we have minus 1. So this k can become power of m. So here this will be log of mod 2 minus x plus root of 2 minus x square plus 1 whole power minus 1. This is acting like k. K will be the power of m. So this minus 1 became the power of this entire log. And this is not plus c as it is. And this is nothing but log of this power. Don't forget, what is a power minus 1? 1 by a. So, see, as soon power is negative, this can go to denominator. Equal sign, this is, can go to what? Denominator. So, this entire term, which is inside the log, can go to denominator. So, we will get 1 divided by 2 minus x plus square root of 2 minus x the whole square plus 1 plus c. Nothing wrong, just setting perfectly. Okay, kindly make a note. We'll take this problem shortly. Okay, dear students, let's take this problem now. See this, see the form. Again, I'm saying don't see this. Just see how we can recognize which formula to be used. So it is integration of 1 by root is a so square root. 9 is a constant, sign is positive, so a square. X square multiple is minus 25, so negative x square. This is sine inverse of x by a plus c. Okay, so now having understood this, in place of a square it is 9. Don't forget a is always positive, so a will be root of 9 is 3, plus or minus 3, but a is positive, so a is equal to 3. In place of x square we have got, so first convert to square. Can't I write this one as 1 by root of 9 minus 5x the whole square. So in place of x we have 5x. Now applying the formula, sine inverse of x is 5x by a, what is a? 3 plus c. Job done. Simple. Now let us again move to this having degree of x, both means x having power 2 and 1, which we also solved last problem model question paper. Let us revisit again and let us take some problem on this. Don't forget, even 7.4 also we are going, 7.7 I mean to say, we are going to have the same thing but in numerator. So as soon we know completion of square, job is done. So here, what was the logic? Recall. So let us take this denominator, x square plus 2x plus 2. Now what we have to do, recall whether it is a plus b whole square or a minus b whole square. First recall the formula. What is a plus b the whole square? It is a square plus 2ab plus b square. If I have minus here, there is a minus here. We are going from right to left. So now if I have got plus, then it is plus 2ab. If I have minus, it will be minus 2ab. So this middle term is the one which will decide whether it is plus a plus b whole square or a minus b whole square. But to apply whatever the trick I'm saying, x square multiple should be always 1. If it is not 1, how to do that also we'll talk. Okay. Now first see this. X, since x is there, x, then what is the sign? Plus. Yeah, plus. Half of 2 is 1. So 1 square. Whatever you wrote, subtract that. Square is only for 1. Then plus 2 as it is. Okay. Let's see. If I expand, am I getting the same? See this? A plus b whole square, no? A square plus 2 into x into 1 plus 1 square, then minus 1 square is again, then plus 2. 1 square minus 1 square and plus 1 square both will get cancelled. Ultimately, I'm going to have x square plus 2x plus 2. That's what we have here. Okay. So now let's continue. This is nothing but x plus 1 the whole square minus 1 square is 1 plus 2. So we'll have x, okay, right here, x plus 1 the whole square. 2 minus 1 is 1. Okay. Now let us integrate this. So integration of 1 divided by square root of x square plus 2x plus 2, nothing but it's here. I think the same problem we had, I think. Anyway, let's complete. What is this now? Oh, that was in terms of tan inverse because there was no root. Now here root is there. Yeah, it is different problem. Now, if I just see this to integrate, here both variable and constants are square term. So let us write the formula here. Integral of 1 divided by root of square of variable and the constant. Square of the variable and the constant is log of mod x plus root of x square plus a square plus c Even though we can see the formula is here, I am writing and showing how to know which one to use. Not just sufficient memorizing the formula, not sufficient. How to use, when to use is very important. Now, if I compare in place of the variable x, we have x plus 1, and in place of a square, we have 1 square. In place of a square, we have 1. Okay, put here. So we are going to have the answer to be log of mod in place of x, x plus 1, then plus root of, again in place of x, x plus 1 square, plus in place of a square 1 plus c. So if I simplify, log of mod x plus 1 plus root of x plus 1 the whole square, x plus 1 the whole square plus 1. If I simplify, I should get back this only. So I can rewrite that. That's it. Okay, so this part, only this part is our rough work for completion of square. Okay, so let us take few more. Okay, dear students, let's continue with some more model on this. See here. Now x square multiple is negative. As I said in the last problem, that the trick which I am giving for that, x square multiple should be what? Plus 1. So now if it is minus 1, how to tackle? See this carefully. I am just going to rewrite this in terms of degree, means highest degree to least degree, least power, minus x square, then minus 6x plus 7. So what is common here? Minus 3. It is not just because common. I have to make x square multiple to be positive. So since negative is there, I am taking negative out. Minus to minus will be plus x square. Minus into minus will be plus 6x here. Minus into plus is minus 7. Now yes, x square multiple is positive. So what we have to do? X here. Then sign is plus. Half of 6. What is half of 6? 3. So 3. Then take a square. Whatever you wrote here, that should be always subtracted. Even if you have minus also, it should be subtracted. We have discussed enough on that. Okay, now then minus 7. Now from here, minus of x plus 3 the whole square minus 3 square will be 9, then minus 7. Square is only for 3, not for minus. So negative remain negative as it is. Now minus of x plus 3 the whole square minus 9 minus 7 will be minus 16. Minus to minus is plus 16. Minus to plus is minus x plus 3 the whole square. Okay, now let us write it. This is question number 12. So integration of 1 by square root of this, nothing but this is here. It is 16. Okay, minus x plus 3 the whole square. Or I can also write 16 is same as what? 4 square, no? So 4 square minus x plus 3 the whole square. So I can write in place of 16, 4 square. Now see, this is of the form 1 by square root of the constant minus square of the variable with minus sign, which is sine inverse of x by a plus c. Okay, so now see carefully. Now applying the formula, in place of a square we have 4 square, so I can say a is equal to 4, and in place of x we have x plus 3. Okay, so substituting here, sine inverse of x is x plus 3 divided by a is 4. Yes, with this, job done. Now the same problem, first make a note. In the same problem, if there is no square root, see carefully. So I am taking a question from my end. Okay, so if I remove the square root, see the change. Now I have removed the square root, and this is the question from my end. Just trying to make you understand. Absolute root is not there. See the change. Surely there won't be any change of making it completion of square. Completion of square doesn't depend whether there is a root or there is not a root there. Now, same thing here. Now see this carefully. These are a form constant square with positive sign, variable square with negative sign. So constant positive, variable negative. What's the formula of this? It is 1 by 2a log of modulus of a plus x divided by a minus x plus c. That's what you can see here, no? The first formula. See, my intention here is 7.4 and 7.7. Both are how to go for completion of square for a quadratic. How are you going to do it, and how are you going to recognize the formulas? Okay. Even for CET also is very important. Now, 1 divided by 2 times of what is a? 4. Then log of modulus of a plus x by a minus x. Nothing but 4 plus x. X is x plus 3. Divided by a is 4 minus x plus 3. And can be a 1 mark question also. 2 4s are 8. Then log of x as it is, and 4 plus is 7, so 7 plus x. And you see the denominator. Can't I write the denominator 4 here? Minus plus is minus x. Minus plus is minus 3. So how much is 4 minus 3? 1 minus x. So this will be 1 minus x in the denominator. Okay, I hope this is clear. All perfect. Yeah. Now let us take one more problem. Okay. Dear students, see here now. 1 by quadratic, but x square multiple is what? 9. Again, I'll take with the root so that the things will be very clear. See carefully. Again, I have to go for completion of square, and this is the assignment on the previous problem. So 9x square plus 6x plus 5. 9 is not common here, and my intention is over that since 9, let us suppose here also had 9 multiples, so I'm taking 9 common. No. The trick which I have given for that, x square multiple should be 1. So I have to make it 1. So since x square multiple is 9, so I'm taking 9 common out. Okay, then what will happen? See this, x square here plus 6 by 9 plus 5 by 9. Very simple, no? 9 into x square will be 9x square. 9 into 6 by 9. 9 by 9 will get cancelled. 6x remain as it is. 9 into 5 by 9. 9 by 9 will get cancelled. 5 as it is. Now here 3. 2s are 3. 3s are. So we are going to have 9 times of x square plus 2 by 3x plus 5 by 9. Now from here, 9 times of x here as it is. In here place is this, so retain place as it is. Here, what is half of 2 by 3? Half of 2 by 3. 2 and half will get cancelled. I'll get 1 by 3. So here it will be 1 by 3 with a square. Then minus 1 by 3 square plus 5 by 9. Now simplify. 9 times of x plus 1 by 3 square minus 1 square is 1, 3 square is 9 plus 5 by 9. So 9 times of x plus 1 by 3 square minus LCM of 9 and 9 is 9 itself. Minus 1 plus 5 will be 4 plus 4. Now we can write as completion of square. This will be 9 times of x plus 1 by 3 the whole square, and 4 by 9 I can write as 2 by 3 the whole square. Okay, so let us write, this is 3 minded. I hope it's looking 3 only. Let us rewrite again. No problem. Now see it very carefully. So we are going to have integration 1 by this entire term which is here is 1 by 9. 9 I will write out of the, okay, first let us write step by step. So I got 9 here. Then x plus 1 by 3 square plus 2 by 3 square. Fine, no? Now see, 1 by 9 is a constant by using the scalar formula, right? I can take 1 by 9 out. I can just say scalar rule only there. Okay. Then this will be x plus 1 by 3 square plus 2 by 3 square. Now see, this resembles which formula? It resembles the formula integral 1 by square of variable and square of constant, nothing but x square plus a square, which is 1 by a tan inverse of x by a plus c. In place of x we have x plus 3. In place of x what do we have? X plus 1 by 3. And in place of a we have 2 by 3. Square and square get balanced. In place of a we have 2 by 3. Let us substitute here. So we will get 1 by 9 as it is. Then this is a, mind it. So into, this is also 9, sorry, a. This is also a. I have a doubt that just looking like 9. So I'm just changing again. 1 by a. What is a? 2 by 3. Then tan inverse of x by a. X is x plus 1 by 3 whole divided by a. What is a? 2 by 3 plus c. Very clearly 3 1s are 3 3s are. So what we are going to have, 2 into 3 is 6. Tan inverse of, there is nothing means 1 here. LCM of 1 and 3 will be 3. So 3 by 1 is 3. 3 into x is 3x. Plus 3 by 3 will be 1. 1 into 1 is 1. Whole divided by 2 by 3 as it is. Without any difficulty, can't we see that 3 by 3 will get cancelled? So what is remaining? Let us write finally here. So the final answer is 1 by 6 tan inverse of 3x plus 1 divided by 2 plus c. This will be the answer. Kindly make a note. Now dear student, the same problem, Q means question from my end. Let us say that we have a root here. We have what? A root. Then what will be the change? Since root is this, see this term, this working will not depend on whether you have root or there is no square root. Now again here also we have a square root. What is square root of 9? 3. So it will be here 3. And this term again inside the square root. Fine. Now formula will change. This is now 1 by root of variable square and constant square. So I'll have this square root of this. Now what is the formula? So from here there will be a change. My intention here is just to see as soon root is there in the question, how the problem will change. Okay, that's my intention. We'll take one more problem after this. See carefully there. So this will be log of modulus of x plus square root of x square plus a square. Okay. Now see carefully. Again, in place of x, x plus 1 by 3, yeah, same. Again, in place of a, it is 2 by 3. Similarly, a square. What will be a square from here? 2 square is 4 divided by 3 square is 9. Let us substitute now. 1 by 3 as it is. Then from here to here. Okay, from here to here. Then log of modulus of x. X is x plus 1 by 3. Then plus root of x, again x plus 1 by 3 square plus a square. A square is 4 by 9. Just giving a root. See how the problem is changing. Now we have got the answer. Just we have to simplify. So this is one single term. So we are going to have our final answer to be 1 by 3 log of modulus of LCM of, there is nothing with 1, LCM of 3 and 1 is 3. So I'll get here 3x plus 1 divided by 3 plus square root of this term. This term is present here, correct? So if we simplify, only 9 should not be there. If we simplify, we should get this term. So let us simplify that. So we will get root of, just see this term is here, correct? No, again this here, then here, then here, then here. If I multiply 9 in, then you will get this. So since 9 is already taken out, 9 is taken out, and this 3, that multiple 3 is there here. So it is going to only wind up here. So it will be x square plus 2 by 3x plus 5 by 9. That's it. 5 by 9. So this part remains the same as the previous one. Now let us take a last problem on this. Okay, dear students, again from 7.4, this problem. See, as soon you see, it's a factor of 2 terms. How to go about? If it is factor of 2 linear factor on multiplying, you'll get what? Quadratic. So first you multiply this. Okay, let I erase this side. How come I didn't erase this side? See carefully now. Pay attention. If I consider this one here, x minus 1 into x minus 2, now multiply, x into x will be x square, x into minus 2 will be minus 2x, minus 1 into x will be minus x, minus 2 minus is plus 2. On simplification, I'll get x square minus, this will be 3x, then plus 2. From here, what? Completion of square you are going to do and get the answer. From here, you are going to have assignment, and one more question will be, see, I have always given the textbook numbering so that it will be easy for you to compare your answer. This actually, either you can multiply this and get this, or you can go for one more method that we will discuss as the next concept. Okay, kindly make a note. Dear students, let us move on to root quadratic concept, that is exercise 7.7. So 7.1 to 7.4 problems on that we have taken. 7.7 let us take, because both are similar, nothing but we are going to use quadratic here, but under the root in numerator. So let us take some problem on root of quadratic. When I say root of quadratic, I want to integrate with respect to x. We mean to say that it is a root of ax square plus bx plus c. Now in this we have got 3 formulae which I have already given, and as I said, we are going with exercise 7.7. Okay, then we'll come back to 7.6 and then further 7.5. Now see the 3 formulas which we have got. First one, integration of root of a square minus x square, which we are also using for application of integrals chapter. Finding the area of circle and ellipse, we are using this formula, and it is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a plus c. This is our first formula. See, let us write properly. Coming to second, integral of root of x square minus a square with respect to x is x by 2 square root of x square minus a square, then minus a square by 2 log of mod x plus root of x square minus a square plus c. Third formula, root of integral of root of a square plus x square with respect to x is x by 2 square root of a square plus x square plus a square by 2 log of modulus of x plus root of a square plus x square plus c. When I gave this formula in the list of formula, I gave you a hint how to remember that formula. Again, let I recall. See, in all this, first thing you see, under the root quadratic is there. Here a square, see, in all these cases a is always positive. Okay, now here you see a square multiple is positive, x square multiple is negative. Here x square multiple is positive, a square multiple is negative. Here both are positive. One question might come, what if both a square and x square multiples are negative? Then under the root we are going to have negative number. Root under the root, if you have got negative, it's a complex number, it's not a real number, so that case will not arise. Now how to remove the formula? See this, see the pattern here. For all this we have got x by 2 and again a square by 2, but here this term is same as whatever we have got in the question. See this? Okay. Now for this we can think of 1 divided by 1 by root of a square minus x square. What is that? Sine inverse of x by a. That's what you can see, sine inverse of x by a. So how to remember this? Very simple. All are constant. So a square by 2, a square by 2, a square by 2. But how to remember the sign? See again, come here. A square sign is here plus. So plus. A square sign is minus here. So minus. A square sign is plus here. So plus. Then coming this one, log of mod of x. Whatever term is there here, same term here. Again, whatever term is the same term. We can give many. No, we can give you the way to remember. Ultimately, you should write and practice and learn. Now, what I will do on all the three, I'll take one problem. And I take all the problem from NCERT text. Okay. Okay, dear students, I have taken some problems here, which will be using, okay, these formulas. First of all, how to know, is recording, no? Yeah, how to know that I have to use this concept very clearly. All are in numerator and root, under root we have got quadratic. That's what I said. And obviously, x square multiple a should not be equal to 0, only then it's quadratic. B and C, anyone may be 0 or both may not be equal to 0. Now see this. I want you to compare like this. See, here a is a constant, x is a variable. So just see here, 4 is a constant, x square is a variable. And see the sign here, 4 sign is positive. 4 sign is, without seeing that, just see carefully how we are going to apply the formula. Integral root of 4 is a constant with plus sign. So a square, and there is no sign mentioned. It's understood that it is positive. Then minus. So minus, then x square. So I hope you understood how to write how to know which formula to be taken. Now from here, our formula is what? X by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a plus c. This is the formula. That's what you can see here. So as soon as the formula is perfect, first the left hand side, knowing left hand side is important. I have explained how to get that. Now see carefully. Now when I compare, in place of a square 4, so a square is equal to 4. This also means that a is equal to root of 4 is only plus 2. A is always positive for all our derivation of 1 by root quadratic, 1 by quadratic and root quadratic. Okay. Next, in place of x it is x only, so no change in the x. X remains x only. Now let us substitute here. So we will get it to be integral of in place of a square 4, in place of x it's x only. So integral of root of 4 minus x square with respect to x is x by 2 root of a square is 4 minus x square, then plus a square is 4 by 2 sine inverse of x by 2 plus c. Very clearly, 2 1s are 2 2s are. Next line we can again write simplified x by 2 root of 4 minus x square plus 2 sine inverse of x by 2 plus c. This part is done. Now let us move on to this. For this, again see carefully which formula to be used. Again, don't see there. See here, root of constant sign is positive. Okay, constant is having plus sign. Then minus. Okay, minus. Variable sign you can see negative. No, so it is x square. Don't think about 4. We will come to know, but only form we have to check. And again, this is same as just now which we wrote. Let us write the formula again. No problem. It will be a good practice. So what will be? X by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. Like this, no, writing and learning is important. Not just going for mind calculation, no eye reading. See, when you do, I didn't know. Things look very simple. From there to there, from here to here, from here to here. Easy. I understood. But when you start writing, no, then comes the problem. I am nowhere clear until unless it is not practiced with understanding, not by mugging. Logic is there. Okay, fine. Rest that. So you have to always believe this hand. Then going for mouth. Mouth will say 101 thing. Tongue don't have bone. It will say many things. We should listen to our hand. If we are getting the solution by solving, only then you should claim that you know it. Otherwise, no. Okay? Recording, no? Yeah. Fine. Now see this carefully. A square is equal to 1. But here x should be a square term, but I got x square and 4. So what I can do is I can rewrite the question as 1 minus 4 is 2 square. So 2x the whole square with respect to x I should integrate. Now when we compare, in place of a square we have 1. And also a is equal to 1, taking note on both the sides. In place of x we have 2x. Again, as I said last time, no, I'm not getting equal sign because student may say x got cancelled. So 1 is equal to 2. Okay. Now let us substitute in this formula. Listen carefully. Integral of root of, in place of a square 1, minus in place of x 2x with a square. So 2x the whole square with respect to x. Again in place of x 2x by 2, root of a square is 1 minus in place of x 2x the whole square plus a square is 1 by 2, sine inverse of x is 2x divided by a is 1. Now be careful, we have learnt under integration x multiple should be divided. What is x multiple here? 2, not minus 2. Minus got balance. We have used a formula where we have got constant to be positive multiple and variable to have negative multiple. Correct? No, negative got balanced. Now x multiple should be divided. So for this entire integration from here to here, since x multiple is 2, we should divide by 2 and plus c. On simplification, 2 and half will get cancelled. So our final answer for this will be integral of root of 1 minus 2 square is 4, then x square dx is equal to 1 by 2 times of x root of 1 minus 4x square plus 1 by 2 sine inverse of 2x by 1 is 2x plus c. Okay, half you can surely think of multiplying in. Now you see this problem. In this problem we have got degree 2 and degree 1. What we just finished in 7 point. Okay, now let us move on this problem. We have got 2x here, nothing but degree 2 and degree 1. We have to go for completion of square the way we did the previous 37.4 exercise concept problem. We did there. So see here, x square plus 4x plus 1. So again, recall what I just said there. There we said that if I have got a plus b the whole square, it is a square plus 2ab plus b square. If we have minus here, then there is a minus here. Correct now? And we are going to come from right to left. So see carefully that x as it is. Then here sign is plus, so plus. What is half of this 4? What is half of 4? It is 2. So 2 here with the square. So now whatever number we wrote, we have to write negative of that. Even if I positive also, it is negative only plus 1. In detail I have discussed in 7.4 just before this problems. You can again go through there. So now why it is, I mean to say why it is always negative even though I have got plus here or minus here depending on this sign. Okay now. So if it is plus here, so then plus. If it is minus here, then minus. But this will be always minus. Whatever term is there, that should be removed here. Now x plus 2 the whole square minus 2 square is 4 plus 1. So this will be x plus 2 the whole square minus 4 plus 1 will be minus 3. You can check whether it's correct or not by using a plus b whole square formula. X square, yeah, here plus 2 into x into 2 will be 4x plus 2 square is 4, 4 minus 3 is 1. Yes, we are getting that. Okay, and having this, now I think I have to erase this. Okay, kindly make a note of this. Now see carefully. Then I take the problem here and I copy the question again. Fourth problem, root of x square plus 4x plus 1 with respect to x. Now integral root of x square plus 4x plus 1 is nothing but x plus 2 the whole square minus 3. X plus 2 the whole square minus 3 with respect to x. Now see carefully again. Don't need to see the formula again. See this here. X square term multiple is positive. So x square minus. Why minus? I wrote here because minus is here. Constant. Okay. So square is not there. A square is 3. So A will be root 3. In all our concept, both constant and variable is square term. Thus we are matching with that. Now in place of x, x plus 2. In place of a square 3. Or in place of a root of 3. Again a is always positive. Repeatedly I am saying this. Now let us apply here. So root of, in place of x it is x plus 2 the whole square minus, in place of a square 3 it is, with respect to x is equal to, yes, now you can see the formula, x square minus a square. In this formula we are going to substitute what it is, x by 2. In place of x, what is that? X plus 2. So x plus 2 by 2, then root of whatever term is the same term. So what is the term here? X plus 2 the whole square minus 3. Then which one is that? This formula we are using. Then minus a square by 2. A square is 3. So minus 3 by 2. Then log of mod of x. What is x? X plus 2. Then plus root of x square minus a square. What is x value? X plus 2 the whole square minus a square. A square is 3. Okay, let's cross check once. We are putting in this formula. So x by 2 plus plus 2 by 2, then root of x plus 2 the whole square minus 3, then minus 3 by 2 log of, yes, all perfect. See, some of the time this will be a multiple choice question where they are going to simplify, and we are being expected to simplify this. Let I erase this side and let us simplify. Okay, fine, I will erase this side. This entire thing I will erase. Anyway, now it is not required. I'll give some assignment problem as well in this. Okay, see this. Now I want to simplify. So see, when you want to simplify, no, many students what they will do, they will think of again expanding by using a plus b whole square. No, not required. Come back here. See, you have expressed this one in completion of square. Surely if you expand this, you should get back what? This only. So as soon you saw, oh, this is same as here. So if I expand, I should get back this only. So directly write down root of x square plus 4x plus 1 integration. Okay, root of this integration. Next what is equal to x plus 2 by 2. Then root of what we have this again x plus 2 the whole square minus 3, nothing but this. So I'll get root of x square plus 4x plus 1. Then minus 3 by 2. Fine, minus 3 by 2. Log of mod x plus 2 as it is. Then plus root of this term is here. On expanding, I'll get x square plus 4x plus 1 plus c. That's it. I hope this is clear. Okay, so simplifications are again a big task. Whatever we have got the question, same thing we are going to write, provided whatever we have got the same expression here, here, and here, that been replaced by the question, because if I simplify, I'll get back the same thing. Fine, let's take one more question on this. Okay, dear students, I have given third and question number 6 to be assignment on the form which we have solved. Now here, question number 5 will be assignment. Question number 7 I'll solve. Here, I have taken a problem. See, whatever the problem we have taken, the trick which I have given, that works only if x square multiple is 1. But it need not happen that it is 1. You can see a -1 is there. How to solve? Let us take that. And this will be assignment. Here, I am taking this problem because when I say x multiple should be divided, what if it is odd number? For even number, I'll get a perfect integer. But what about this type? That's why I have taken this problem. See, I'll take in working column. First, I'll try to go for completion of square of this. Let I write in order. First, degree 2 term, that is minus x square. Then degree 1 term, that is plus 3x. Then the constant plus 1. Now, since x square multiple should be always what? Plus 1. Since I've got minus 1 here, so I'll take minus common. Minus to minus is plus x square. Minus to plus minus into plus will be minus 3x. Minus into plus will be minus 1. Okay. Now, same old story. X, then sign is minus. What is here? 3. What is half of 3? 3 by 2. So 3 by 2. Then square. Whatever I'm writing, same term here, but with the minus sign always. 3 by 2 whole square. Then minus 1 is there here. This minus 1 I am rewriting as it is. Again, let us repeat why even though I've got minus here, why minus is written, why it is not plus. For a while, expand this. Recall what is a plus b and a minus b whole square formula. Coming to a plus b whole square formula, it is a square plus 2ab plus b square. For a minus b whole square, a square minus 2ab plus b square. So in both the cases, you see this b square term and a square term multiples are what? Positive. Only 2ab is deciding. If 2ab multiple is positive, it's a plus b whole square. If 2ab multiple is negative, then this a minus b the whole square. From right to left we are moving. So now if you just see and expand this, no, only the bracket term, okay, minus I will written as it is, no problem. So this a minus b the whole square. So x square minus 2 into x into 3 by 2 plus 3 by 2 the whole square. See, this I have expanded. Minus 3 by 2 the whole square I write as it is, then minus 1. Now you see carefully, minus 3 by 2 whole square plus 3 by 2 whole square will get cancelled. 2 and a half will get cancelled. So I'll get x square, yeah, x square. Then 3 into x into minus will be minus 3x, then minus 1 as it is. So what we have understood here is that whether it is a plus b whole square or a minus b whole square, b square is always going to have a plus sign. So it means when I'm going to expand this, this will be 3 by 2 the whole square. For nullifying that, we have always given minus 3 by minus here. So whether it is plus here or minus here, ultimately on expansion, we will get the plus square. So to nullify this, always minus square of this will be written. Okay. Now, let us complete. So on simplification, minus of, we are going to have x minus 3 by 2 the whole square, then minus 3 square is 9 by 4, then here minus 1, then again minus of x minus 3 by 2 the whole square, 4 is the LCM, so minus 9 as it is, because 4 by 4 will be 1, 1 into minus 9 is minus 9, plus will multiply after getting the entire simplification. Here nothing is there, means 1, 4 by 1 is 4, 4 into minus 1 is minus 4. Okay, this minus 9 minus 4 will be minus 13, correct now? So minus into minus will be plus 13 by 4, minus to plus is minus x minus 3 by 2 whole square. So this will be on completion of square. So let us write it here. Square root of 13 by 4 minus, okay, again 13 by 4, okay, let us go directly, no problem. Then x minus 3 by 2 square dx here, okay. Now see carefully which formula can be take it. For that, aram se see carefully. Root constant sign is here positive, so plus a square. Variable sign x is negative here, so minus x square over. We came to know our formula. So this formula we know it is x by 2 root of whatever term is the same thing. Then plus, since a square is here, so a square by 2, and it is sine inverse of x by a plus c. Okay. Now in place of a square we have 13 by 4. Or I can say, since I want a value also, take the root on both the sides, square root on the both the sides. A is equal to square root of 13 divided by root of 4 is 2. Again, in place of x minus 3 by 2. So now let us substitute all the values here. So integral root of a square is 13 by 4 minus x square. What is the x value? X minus 3 by 2 the whole square. Okay, with respect to x is equal to x. What is x? X minus 3 by 2. Then half. So I let half out. Then root of a square. So come on. A square is 13 by 4. You can just substitute. Minus x value is x minus 3 by 2 the whole square. Plus again half a square. A square is 13 by 4 into sine inverse of x by a. What is x? X minus 3 by 2. X by a. What is a? Root 13 by 2. See carefully. X in place of x, x minus 3 by 2 and what? Then a. What is a? Root 13 by 2. Recording, no? Many times it has happened. I have 2 to 3 times. I have on, without on recording, I have started explaining and again I have refuted. So always I try to recheck. Now see carefully. I have to simplify. I'll simplify here only. Bottom side is visible. Yeah, visible. Root of this. No, it again simplify. This is same as this term. So on simplification, and you should get back this only. So it is what? Minus x square plus 3x plus 1 with respect to x is, here LCM is nothing there. LCM of 2 and 1 is 2. So I'm going to have half as it is. LCM of 2 and 1 is 2. 2 by 1 is 2. 2 into x will be 2x. Minus 2 and half. 2 and half will get cancelled. I'll get 3 ones are 3. Then again square root of this entire term is here. And we are going to have minus x square plus 3x plus 1. Then plus 13 into 1 is 13. 2 into 4 is 8. Sine inverse of, there is nothing here, it means 1. LCM of 2 and 1 is 2. 2 by 1 is 2. 2 into x is 2x. 2 by 2 is 1. 1 into minus 3 is minus 3. Then whole divided by root 13 by 2. Okay, space is not there. So what I will do is whole divided by root 13 by 2. Okay. Visible now? Yeah. Now see carefully. This 2 and half will get cancelled. So the final answer I'm going to note down. I hope this is made a note of that. Now see the final conclusion. Problem is not difficult. Simplification is more. Okay. Simplification is more. So the final conclusion I'm writing here. Therefore, integral of root of, whether it this one or in this form, both are the same. So minus x square plus 3x plus 1 with respect to x is equal to 2 2s are 4. So 2x minus 3 divided by 4. Then this root term as it is, that is minus x square plus 3x plus 1. Then here plus 13 by 8. Sine inverse of what? 2x. Hmm. 2x minus 3, just I rechecked, divided by root 13 plus c. This is our final answer. Okay, kindly make a note of this. Okay, dear students, let us take some more problem, then we'll go for next concept. See, again, root quadratic. Here, when you see degree 2 and degree 1 is there, constant is not there. I'm just trying to take this problem to make you understand there won't be any change in the concept. Again, if I just go for completion of square, x square plus 3x is there. So again I will write x, then sign is plus. Half of 3. What is half of 3? 3 by 2. So I write 3 by 2. The whole square. Whatever I wrote inside, that should be always subtracted. Correct? That should be always subtracted. Now I'm going to write that one here. Integral root of this entire thing is here. X plus 3 by 2 square minus 3 by 2 square with respect to x. Now see this carefully. It resembles the formula. Which formula? See carefully. Root of, by root because it is there. Here variable x is square minus constant also square. So it is x square minus a square with respect to x. So here it is x by 2 square root of x square minus a square by 2 log of mod x plus square root of x square minus a square plus c. Okay. Now compare it. In place of x we have x plus 3 by 2. And in place of a we have 3 by 2. A square. Actually I can see a square is what? 9 by 4. Correct? No? Squaring this. And what is a? 3 by 2. Okay? Write it here. Fine. Let's continue. Now very clearly we can write in this form, if I substitute wherever x is there, x plus 3 by 2. So here half out. Then what is x? In place of this x, it is x plus 3 by 2. Then root of again x plus 3 by 2 square minus a square is 9 by 4 minus half. Again a square. What is a square? 9 by 4. Log of mod x. X is x plus 3 by 2. Then plus square root of. Again in place of x, x plus 3 by 2. The whole square minus a square is 9 by 4. I hope this is clear. Fine. So let us check once. Half, then x square term minus half. Okay, all fine. Now simplification. Nothing is happens 1, no. LCM of 2 and 1 will be 2. So let us write that this term here only. This term. LCM of 2 and 1 is what? 2. Then 2 by 1 is 2. 2 into x is 2x. Plus 2 by 2 will be 1. 1 into 3 is 3. So this is 2. So what we have got here? This 2x plus 3 into this one will be 2x plus 3 divided by 2 into 2 will be 4. Then root of this term. This term is present here. Don't forget, write for you here. This is actually what? X plus 3 by 2 the whole square minus 9 by 4. Correct? No? Write 3 by 2 the whole square, 9 by 4 both are same. So this term is here, and which on simplification will be again by this itself. Then 9 ones are 9, 4 twos are 8, log of, again there is nothing yet means 1, LCM of 2 and 1 is what? 2. So I get 2 by 1 is 2, 2 into x is 2x, 2 by 2 is 1, 1 into 3 is 3. Then root of this entire is here, nothing but x square plus 3x plus c. Okay, we have got the solution. Now let's see this problem. Here, in place of now taking as x by 3 whole square, you can take LCM. It will be simple for us. See carefully. This is integral of root of 1 plus x square by 9. So 9 is the LCM. There's nothing here, it means 1. LCM of 1 and 9 is 9. 9 by 1 is 9. 9 into 1 is 9. Plus 9 by 9 is 1. 1 into x square is x square. Be careful. Root are given for both numerator and denominator. Root of 9 is 3. It's in there. This 9 is the denominator. So root of 9 is 3. It is in denominator. Then integral of root of 9 minus x square. Sorry, 9 plus x square. Now from here, simple calculation. See carefully. This resembles the form root of integral of root of constant is positive, variable also positive. So it is a square plus x square. Integration of this is x by 2 root of a square plus x square plus a square by 2. Then log of mod of x plus root of a square plus x square. Is this visible? Okay, visible. Now see carefully. In place of, see, I'm not going with this. I'm going to apply integration for this. Okay. So 1 by 3 out as it is scalar rule. Now I have to apply for this. So if I compare in place of a square, we have 9. Let us write it here. In place of a square, it is 9. Nothing but, yeah, everywhere is a square, so nothing to write for a. And in place of x, it is x only. So here, substitute x by 2 square root of a square is 9 plus x square plus half as it is. What is a square? 9. Then log of mod of x plus root of a square is 9 plus x square plus c. And this 1 by 3, since it's a multiple, so close the bracket here. Simplify. X into 1 is x. 2 into 3 will be 6. Square root of 9 plus x square. Now here also 3. When I multiply in here, just see carefully. 3 ones are 3 threes are. Correct now? When I multiply this 3 in here, 3 ones are 3 threes are. So I'll get 3 by 2. Here I'll get 3. If when I divide 9 by this 3. So 3 threes are 9. So 3 by 2 I will get here. Then log of mod x plus square root of 9 plus x square plus c. Okay. Kindly make a note of this. Dear students, now let us move on to the next method of integration, that is integration by partial fraction. Right method also, partial fraction method. Now what we are going to do in this method? Let's first understand some basic things, then I'll come to what actually to be done. See, let us first recall what is polynomial. What is polynomial function? Any expression of the form p of x is equal to a naught x, okay, a naught plus a1x plus a2x square plus a3x cube plus dot dot dot, nothing but we are going to have finite number of terms. It should be a finite, okay? Only then polynomial is defined. It should be a finite expression, an x power n, where an is not equal to 0 and this n is a whole number, or we can say non-negative integer. When I say non-negative integer, it is, just understand what's the meaning of the word non-negative integer. 0 is here, then 1 here, 2 here, minus 1, minus 2. When I say positive integer, starts from 1, 2, 3. Negative integer, minus 1, minus 2, minus 3 moves on. Correct? 0 is neither positive nor negative. When we use the word non-negative integer, means what? It should not be negative. When I say it should not be negative, this part is gone. Only start from 0, 1, 2, 3, moves on. That is what? Whole number, no? So n is a whole number. Now here we say this is a polynomial of degree n provided x power n multiple, that is an, is not equal to 0. Only then we say it's a polynomial of degree n. And what are this a0, a1, a2, a3 up to an? These are any real numbers. So all ai's when I equal to 0, a0, when I equal to 1, a1, when I equal to 2, then 3 up to an. All are what? Real numbers. Now let us understand one more. Before that, example. See this. For example, x square plus 7x power 3 minus 5. This is a polynomial of degree 3. This is a polynomial of degree 3. By degree 3, highest power is what? 3. And you see, x square, x cube, what are the term is written here? Power is 2, 3, and there is no power. All are whole number. And the coefficient can be any real numbers. I can have here root 5 also, no problem. Whereas this is a polynomial. First of all, this is a yes polynomial. Since it's a polynomial, well, that is the reason I have given degree. Let us suppose I will give an example like this: root x plus x power 10 minus 7. Now this is not a polynomial because power of x is here half. Half is not a whole number, not a polynomial. Not a polynomial. Hence, degree undefined. Only for polynomial degree is defined. Okay. I hope you have got a clarity about what is polynomial. Let's take one more example. Let us suppose I give you x power 3, okay, 2, then minus 1 by 3 x power 10, then plus root 2 x power 3. This is again a polynomial because you can see power 2, 10 and 3 all are whole number, and multiples can be any real numbers. And this is again a polynomial, and here the polynomial degree is what? 10. Yes, polynomial and degree is 10. I hope this logic is clear. Now what about rational function? What is rational function? Any function f of x of the form p of x divided by q of x, where q of x is not equal to 0, and both p of x and q of x are what? Polynomials. Are polynomials. Okay, polynomial function. Better. Now, coming to rational function, depending on the degree, since we said polynomial, it should have some degree. Now, before we go ahead, forever, let's first take some example. Example number 1. X minus 2 divided by x power 2 minus 7x plus 10. This is a rational function because both numerator, denominator are what? Polynomial. When I say polynomial, you should obey this condition. Okay. Now, see this one example. And one more example I will take. X power 3 minus 7 divided by x square plus 4x. Just some random example I am taking. Now here, see, this is numerator, this is denominator, correct? No? So if you see this, in this particular rational function, the degree of numerator is 1, degree of denominator polynomial is what? 2. So here, degree, I write DEG for degree of, in this numerator, highest power is 1 here, so degree is 1. Coming to the denominator, degree of denominator is what? 2. So here very clearly you can see 1 is less than 2, nothing but degree of numerator is less than degree of denominator. This we call proper rational function. What we call? Proper rational function. What is proper rational function? Proper rational function. It is a function, rational function, in which degree of numerator is less than degree of denominator. Whereas you see here, what is the degree of numerator and denominator? The degree of numerator is 3, and here the degree of denominator is 2. Now very clearly 3 is more than 2. Nothing but what is 3? Degree of numerator. Same thing here also, no? Here 1 is less than 2. What is 1? Degree of numerator. What is 2? Degree of denominator. So here degree of numerator is greater than degree of denominator. Not only that, even it can be equal also. Whenever degree of numerator is greater than or equal to degree of denominator, then we call it is improper rational function. What we call? Improper rational function. But every improper rational function can be converted to a rational function by usual long division method, which will carry out later. Now, one more example I can just say. X square minus 7x plus 2 divided by 2x square minus 3x. Now you see, degree of numerator is 2, denominator also 2. Okay, this 2 is this one, this power. Okay, and again it comes under improper rational function because it obeys that it can be equal also, greater than or equal to. So now having this, let us try to proceed how we are going to go for this partial fraction method. Okay, fine. Kindly make a note. Now dear students, let us try to focus on how are we going to adopt this method to solve our problems on rational functions. See carefully. Presently, whatever we are taking, all are under proper rational function. When I say proper rational function, don't forget that for this, degree of numerator should be less than degree of denominator. So whichever method I'm talking about, the three category, all are under rational, proper rational function. Now the first one, and all are going to depend on the denominator. Now just see carefully the first one. If I take in general, px plus q divided by x minus a into x minus b. See carefully. If you multiply this, x into x is what? X square. So the degree of denominator is 2, degree of numerator is 1, nothing but it's a proper rational function. Now focus on denominator. Here, this is linear non-repeated factor. When I say linear, power of each of the factor is 1, and it's non-repeated, nothing but each power is what? 1. Since power is 1, it's not repeated. Now what we are going to do here is, we are going to decompose this into linear factor. So all it is linear. See this? X minus a, then x minus b, and the constants are here a plus b, where a and b are the constant to be determined, and it's linear, so same thing linear here. And this will take us type 1. So type 1. So coming to type 1, this is non-repeated linear factors. Again, let me be very specific. Denominator is non-repeated linear factors. You can see now, linear, yeah. Linear is what? Highest power should be 1, yes, and it is non-repeated. We can have this is one example, okay, on this side. We can have one more. Let us suppose I got a quadratic. Since it's a proper, my denominator should be a cubic. Nothing but I've got 3 factors here. Again, there's nothing like, no, since I use small a, I have to use capital A. No, you can use any alphabet. Now again, this is a proper rational function in which denominators are linear factors and it is non-repeated. Okay, so for that, again, first factor, then second factor, then third factor, and then a plus b plus c, where a, b, c are the constant to be determined. Capital C it is. Okay, this c is different from this c. Okay, this is some small letter c, same thing I written, and this is capital C, where we have to determine. Now coming to type 2. See here we said denominator is non-repeated linear factor. Now coming to type 2, it's again linear factors, but it is repeated. So denominator is repeated, okay, and non-repeated, okay, and it's a linear factors. I can have one factor or more than one factor, no problem. I write as factors there. Now, for example, see this in general. Let's suppose I got px plus q divided by x minus a the whole square. This is a linear factor but repeated twice because power 2 is there. Then how are you going to solve this? Write down the linear factor first with power 1. Then next power 2. Then again the constant a plus b, where a and b are the constant to be determined. Let us suppose that you have got, example b, you have got something like this, px plus q divided by x minus a the whole cube. Then what you are going to write? A divided by x minus a plus b divided by x minus a the whole square. Till you are not going to reach till cube, you are going to write the factors just by incrementing by 1. Here 1, then 2, and here lastly 3. As soon we have reached, stop. Again, where a, b, c are the constant to be determined. See, we can also have a combination of, see here I have taken both the times denominator is repeated. Here it is repeated twice and here it is thrice. What if I have something like this? A quadratic is there divided by x minus a the whole square into x minus b. X minus b is linear and it is non-repeated. X minus a is linear but repeated twice. So this will be a divided by x minus a plus b divided by x minus a the whole square plus c divided by x minus b. This is clear. Again, where a, b, c are the constant to be determined. Now, here you see the one which is repeated, you can see twice. So first we got with power 1, then power 2, and the non-repeated as it is. Now comes type 3. See, in type 3, denominator is non-factorizable. Type 3. Denominator is non-factorizable. See one such general example. If I take px plus q divided by ax square plus b. Now you cannot factorize. If you had a square minus b, then a plus b, a square minus b square is equal to a plus b into a minus b. That logic you could have applied, but here it is not the case. Then how are you going to simplify? Simple. See, since it was a linear factor, here the numerator is a constant. Here also, see carefully, it's a linear, so numerator is constant. But since here it is a quadratic, the numerator should be a linear factor, nothing but ax plus b, where a and b are the constant to be determined. And throughout, if you see, there is no integration sign. Means what? We are going to take the problem separately. First, we are going to simplify, and then we are going to integrate. And you can just see here, compared to this is all easy to integrate. And as soon we express in the form, in this form, it is of the form 1 by x. What is integration of 1 by x? Recording, no? Integration of 1 by x what? Log mod x. And this is of the form, here also 1 by x log mod x. Nothing but back to first exercise, or this is a formula. Here also 1 by x form. This is 1 by x square form. What is integration of 1 by x square? Minus 1 by x. So ultimately, this will be easier compared to this. Now let us say one last form, means last example. Px square plus qx plus c divided by ax square plus b into x minus c. This is linear factor, there is no problem with this. Okay, pq, I write it here r, let us not repeat the letters. Now here, this is non-factorizable term. So for this, again I'll have linear ax plus b divided by ax square plus b plus c divided by, capital C divided by x minus c. So again a, b, c, again let's write that, where a, b and c are constants to be determined. Now one more thing I want you to understand. See, all are type 1, type 2, type 3, depending on the denominator, all are under proper rational function. Now improper rational function, purposefully I take as type 4 so that student will remember, no, oh, we have type, totally how many types? 4 types. Only then the student remembers, no, always I have to first see whether my question is proper rational function or improper rational function. So now first we make a note, we discuss about improper rational function. Okay, before going to type 4, here one more example I would like to take. It can be of this form also, px square plus qx plus r divided by, let us suppose now I've got some factor x minus a and I have got a quadratic of this form. Okay, q is used, no, c I will take. And this, let us suppose we are not able to factorize, non-factorizable. Okay, then again, since this is a linear, so a divided by x minus a plus, this is non-factorizable term, I will write as it is here, bx square plus cx plus d. So here it will be bx plus c, again linear, that's what, no, here I just gave in the form ax square plus b where x multiple is 0, but x multiple can also be present. Okay, it can be non-zero also. Now coming to type 4, as I said, we'll take as what? Improper rational function. Improper rational, we'll have a capital R, rational function. Now what we are going to do here, just simple logic. Whatever improper rational function is there, we are going to convert to rational function by suitable long division, means the by long division method. For example, let us suppose we have got p of x divided by q of x such a way that degree of the numerator p of x is greater than or equal to degree of the denominator. Then what we are going to do is we are going to divide them. Now see, when I divide, I'm dividing p of x. So p of x is divided by q. Okay, this is how you do, no. Now when I'm dividing, surely I'll get some, okay, some remainder here, sorry, some quotient here. Let's say quotient is some t1. Okay, t, I'll take t, and here after I divided, I've got some remainder as p1. Okay, or for you r1, no problem, r I will take. Then how we are going to write this? This will be quotient plus remainder divided by quotient. Don't forget, in our usual long division process, we are going to divide this until and unless remainder degree is not less than divisor degree. As soon as this degree, the degree of the remainder is less than degree of what? The divisor, we are going to stop dividing. If it is, if this division, if p of x has got a perfect factor of q of x, then surely this remainder will not be there, it will be 0. But if it is not perfect factor of the denominator q of x, then we'll get some remainder like this. If you just go for our school days, now means I with respect to the numbers, see carefully. If I have given you 9 by 2, when you are going to divide this, in a usual way, what do you do? 2 4s are 8, correct? No, 2 4s are 8 divided by, means 2 4s are 8, borrow is 1. So how you write this? Quotient plus remainder by divisor, correct? No, take the LCM. LCM will be 2, 2 4s are 8, 8 plus 1 9, 9 by 2. Same thing here, you see. 2 is the divisor. Yeah, divisor is what? Quotient, correct? No, quotient. So you can see quotient. Next, 1 is the remainder. What's the remainder here? Yes, here. Then 4 is what? Quotient. I repeat again. 4 is the quotient. Yeah, 4 is the quotient. So in place of quotient, we have t. Then remainder is 1, divisor is 2. Correct? No, remainder is r, divisor is q. Same thing it is. And this will be a proper rational function. Proper rational function. Rational function. And as soon we get proper rational function, it will be, I mean to say, we are going to apply one of the three types. Either type 1 where denominator is non-repeated linear factor, or type 2 where denominators are repeated factor, or type 3 if it is non-factorizable. Okay, fine. This is the concept. Now we are ready for the problems. Okay, dear students, now let us move on to the problem. Coming to model question paper, it is asked from model question paper number 1 of this academic year 2025-2026. As you know, it's from PU board, I mean say KSEAB. Now here, what has happened now? They have given only one question from partial fraction, but to complete with all the problem now, I mean it's a concept, I'll be taking 3 more problems, each on type 2, type 3, then improper rational function, and then we'll take the last concept, integration by parts. Okay, now see this. Integration, or means integrate, question number 35 for 3 marks. We have to integrate this with respect to x by partial fraction method. This method name need not be specified. Okay, now if they have mentioned, you have to go with the method which I am going to teach. Why I'm using this word? No, you have to go with this method if they are given. Other methods also there, linear by quadratic, that is then 7.4. Okay, now let's complete solution. Coming to the given question, we have to integrate this. So let I give the integration sign. Now I'll take this as equation number 1. Let us consider the integrand. Recording, no? Yeah. Let us consider the integrand. What do we have? X divided by x plus 1 into x plus 2. Now, as you can see, degree of denominator x into x is x square, so it is 2. Degree of numerator is what? 1. Therefore, it's a proper rational function. Not only that, under proper rational function, if you see denominator, these are non-repeated linear factors, so it's type number 1. That's why I give type 1. Now here it is a divided by x plus 1 plus b divided by x plus 2. For your kind information, this I just wrote the heading so that when you are viewing, you should understand that I have taken an example on type 1. The question is only this. Okay, these all are I have just mentioned so that you understand that I am taking on type 1. Now a and b are the concept to determine. Now what you are going to do is see this. What we have decomposed, we have break this into 2. This will be very easy to integrate, but I want to find a and b value. Now what you are going to do is a fraction separated by sign plus, so I have to take LCM. Many times students will have a trouble by taking the LCM of this. For that, very simple logic, whatever is in the left hand side, that's your LCM. LCM will be what is in the left hand side denominator, so it will be x plus 1 into x plus 2. Then left hand side as it is. Now the denominator divided by x plus 1 will remain what? X plus 2. So a into x plus 2 plus the denominator divided by x plus 2. X plus 2 will get cancelled, remaining what? X plus 1 multiplied to the numerator. That's what we used to do, no? If I got 1 by 2 minus plus 1 by 3 by 7, for example, how will you take LCM? How you are going to proceed from here? LCM of 7 and 2 is what? 14. Then 14 divided by 2 is what? 7. That you multiply numerator. So 1 into 7 is 7. 14 by 7 is what? 2. That you multiply to numerator. 2 into 3, 6. Same thing we have did. In place of numbers, we have got some factors. Now you see carefully, this will get cancelled. Our target is to find the value of a as well as b. Now we will have x is equal to a into x plus 2 plus b into x plus 1. Now this step, from this step we are going to find the values of a and b. This is our equation number 2 I will take, and this I will take as 3. Now how to determine a and b? Just equate their coefficient, means the variable x, whatever the terms you have got, factors to 0. Why sir, why should we equate? Very simple. If I equate, see here we have 2 unknowns, which are those? A and b. One equation, one unknown, easy to solve. So what we are trying to do is taking each of the factor equate to 0, and as soon as I equate to 0, see this, x plus 2 is 0, so this is gone, 0 into is 0. Then only b will be remaining with x value. What is x value? Transpose this. X is equal to minus 2 in equation number 3. So we will have minus 2 is equal to a times of x plus 2 is 0 plus b. What is x value? Minus 2 plus 1. So what we are going to have? Minus 2 plus 1 will be minus 1. Minus 1 and a into 0 is 0. A is not 0. Since a is multiple of 0, so product of this two is what? 0. So I'll get minus 2 is equal to minus 1 into plus will be minus. So minus b I will get. Negative will get cancelled here. Then what we are going to have? B is equal to 2. So we got one of the value. Now what we are going to do, equate the next factor to 0. So put x plus 1 is equal to 0. This will give us x is equal to minus 1. Again, if I put in equation number 3, what we are going to have? In 3, we are going to substitute x value. In place of x value, we have got minus 1 is equal to a times of x plus 2. In place of x, what do we have? Minus 1. So minus 1 plus 2. Then plus b times of what is x plus 1? 0. B into 0 is 0. And minus 1 plus 2 will be 1. And here you can see, 1 into a is a. So minus 1 is equal to a. We got other constant value also. And this I will take as equation number 4. And this we will take as equation number 5. Now, put equation number 4 and 5 back in 2 and also integrate. Why integrate? Don't forget, question was with the integration. We have taken only the integrand and we have split it and make to our convenience to integrate. So now put what equation number 4 and 5 in equation number 2 and integrate with respect to x. So as soon as I have said that, coming to equation number 2, for this I am going to give integration symbol also because I want to integrate. So now what we are going to have? X divided by x plus 1 into x plus 2 with respect to x is equal to a. What is a value? Minus 1. So minus 1 divided by x plus 1. Then b. In place of b, what? 2. So 2 divided by x plus 2 with respect to x, we have to integrate. Now let us integrate one by one. Now this, as we know, is of the form 1 by x. What is integration of 1 by x with respect to x? It is log mod x plus c. So minus as it is. Integration of 1 by x plus 1. See, since I have got 1 by c, 1 by linear. Correct? No, 1 by linear. Yeah, 1 by linear. Power is 1 of denominator. So integration of 1 by x is log mod x. So whatever is there here, same term came inside the log. So here I got x plus 1. So log of mod x plus 1 plus 2. Scalar rule I am applying. 2 is out. Again, this integration of, this is what now? 1 by x plus 2 will be what? Log of mod x plus 2 plus log c, the constant. Whether you want to write log c or only c, left to you. But since all are in terms of log, I have taken log c. Now recall some of the property of log. What is k into log m? It is log m power k. Integration completed, just simplify. And what is log m plus log n? It is log m into n. Nothing but if you sum, it will be a product. Then what is log m minus log n? It is log m by n. Now you see carefully. Here, if you see carefully, log sign is minus here and log sign is here plus. So this is of the form, this one, log m minus log n. So we are going to have log of c by this. Okay, under the mod. Then this, by using this property, k log m is what? Log m power k. So this 2 will jump up. So we will have log mod of x plus 2 the whole square. Okay, now this will come log m plus log n. What is log m plus log n? Log m into n, correct? No. So going with this property, we are going to have log of mod of x plus 2 the whole square into c divided by x plus 1. all are under the mod. This is our final answer. Okay, I hope this is clear. Now, first make a note. I'll also give you a hint how to know whether your value of A and B is correct. One short trick I will give you to get the answer directly, and you can always cross check. Now see the short trick. Problem done. Okay, and what short trick I'm going to teach, don't apply an examination. Even if I'm the evaluator, I'll give you 0 only. Okay, if you apply the short trick, which I'm going to teach you now. What the short trick is, see carefully. Whatever is there in denominator forever equal to 0, what will you get? X is equal to -1. Correct, no? So come to the left hand side. The term which you have equated to 0 in denominator, cover that. Why covering, sir? If I put x value -1 here, -1 plus 1, you got 0. Surely you'll get 0 because by equating this factor to 0, you got the value x equal to -1. So first cover that. Now, here in place of x, -1. Okay, into x plus is what? -1. -1 plus 2 is what? 1. So -1 by 1 is what? -1. -1 by 1 is what? -1. That's what we got here. See, both are same. Again, I repeat. Equate the factor to 0 and get the root. That is -1. Cover that factor which you have equated to 0. That is this factor. Then wherever x is there, put as -1. So and when you are substituting numerator to numerator, denominator to denominator. Okay. So x is -1. Then here -1 plus 2 will be what? 1. 1. 1 you will get here. What is -1 by 1? -1 itself. So you will get this. Again here also equate this one to 0. If I equate to 0, I will get x is equal to -2. Which one you have to cover? X plus 2. Cover it. Now what you get here? -2. I write -2. Then in place of this x, -2. What is -2 plus 1? -1. Then negative will get cancelled. 2 by 1 is what? 2. 2 divided by this. Yeah, 2 divided by this. Okay, we got that. Fine. So this trick you can apply to cross check is it correct or not. Like this, when we start see it, many tricks will be there. But repeatedly I'm saying, we are not going to ignore concept. Without concept, nothing it is. Kindly make a note. Okay. Yeah, I just saw that it may not be visible, this part. So I'm just rewriting again here. Okay. See this. This is the form log. This entire thing is m plus n. Correct. What is log m plus log n? Log m into n. So it is log. What is m? This. So c divided by x plus 1. Okay. Then plus, whenever it's plus, the term will be multiplied. So this will be multiplied, and it is here x plus 2 the whole square. Then this is under the modulus. Okay, fine. Same thing I wrote here. Kindly make a note. Okay. Oh, question. Okay. Dear students, having completed the model question paper problem on partial fraction type 1, this is the assignment for you. And here you have to factorize. See this, if I factorize, coming to denominator, since it's a degree is 2 and degree is 1, is a proper rational function. And if you factorize this, we are going to have x square plus 3x plus 2. 1 into 2 is 2. So 2, if I divide, 2 1s are 2. So 2 plus 1 is 3. So factors will be 2 and 1. So I can write 3x as 2x plus x plus 2. Correct? Then here common is x. So I'll get x plus 2. And then here there is nothing common. So I can say it is 1. So I am going to have x plus 2 again. So the common is x plus 2 and the other is x plus 1. Now you can see the denominator x square plus 3x plus 2. On factorizing, we have got a factor x plus 2 and x plus 1 which are linear and non-repeated. Therefore, it will be under type 1 and then you are going to proceed the way I have taught you. Now let us take a problem on type 2, which is now the type 2, type 3 and improper rational function problem which I'm going to take. Those are not asked in model question paper. But as I said, I want to complete all the concept, so I'll be taking the problem from NCERT text. Kindly make a note of this. Okay, dear students, let us move on to type 2. See, as I said, no question, they may not mention which method, partial fraction method or not, but just in the small paper they have mentioned. Okay, usually they'll never mention. Now you see, if I consider the integrand, that is 3x minus 1 divided by x plus 2 the whole square, it's a linear factor but repeated twice. So it comes under type 2. Denominator having repeated linear factors. Okay, with repeated linear factors. So now here, how we are going to solve? A divided by, first write down with degree 1, then plus b divided by x plus 2 the whole square. Now take the LCM. That's what I said. No, many students will have a doubt on taking the LCM. That's what I said. Whatever is in the left hand side in denominator, that's your LCM. So I want to learn how to take LCM. Simple. Think this as some d. This will be what? D square. What is LCM of d and d square? Divide by d. D ones are d. Then here d square by d will be d. Correct? No. Again d as it is 1. D ones are d. D into d, d square. LCM will be d square. Correct? No. We are going to divide. If it was a number here 2 and 4, we divide by 2. Then again divide by 2 until you won't get 1. Same logic. Okay. Now x plus 2 the whole square divided by x plus 2 will be only x plus 2 is remaining. So a into x plus 2 plus b into x plus 2 whole square by x plus 2 whole square will be 1. Then we are getting here 3x minus 1 divided by x plus 2 the whole square. Now see here very carefully that x plus 2 the whole square in the denominator will get cancelled. Now what is remaining? 3x minus 1 is equal to a into x plus 2 plus b into 1 is b. So this is our equation. Now this I will take as equation number 1, and this entire thing I will take as equation number 2. We have to determine both a and b so that we can substitute and get the answer. Now for this, I'll take this as equation number 3. So I have to find a and b. Very simple here. Equate like last time. Since I have got a and b two unknowns, I want to have one unknown because I have got only one equation. So its multiple is x plus 2 equal to 0. So if I put x plus 2 is equal to 0, this will give me x is equal to, transpose this, minus 2. So wherever x is there, replaced by minus 2 in equation number 3. So 3 times of, in place of x minus 2, then minus 1 is equal to a times of x plus 2 is what? 0. Even if you put x is equal to minus 2 plus 2 is what? 0 only. Plus b. What is a into 0? 0. So 0 plus b is b. 3 into minus 2 is minus 6 minus 1. So minus 7 is equal to b. We got the value of b. Now, like last time, no, we don't have one more factor here to equal to 0. Why we don't have one more factor? Because this time it is repeated. Correct? No, last one was non-repeated, due to which we got for each a and b one factor multiplied. Then how to solve? Very simple. Take this equation number 3 and simplify. So I'll take this as equation number 4. Now you see, consider, I'll write it here. Consider equation number 3. What do we have in equation number 3? 3x. Okay, I'll write it here. 3. Okay, I'll write it below. 3x minus 1 is equal to, copying this, a times of x plus 2 plus b. Now let us multiply a in. A into x will be ax. A into 2 will be 2a plus b is equal to 3x minus 1. So ax. Okay, enough. Nothing more to simplify. Now see, I have got one equation, a linear equation. See, when we say coming to equation in terms of polynomial, when do we say they are equal? Their coefficient should be same. If I got x square on either side, coefficient should be same. So for each and every term of the variable x, what are the power we have got on both the sides, their coefficient should be same. Coefficient means, for example, here 3x. 3 is a constant which is multiple to x. So 3 is called coefficient. Minus 1 is just a constant. Understand the difference between coefficient and a constant. Actually speaking, both are constant, but 3 is multiplied to variable x, so we regard 3 as what? Coefficient. So as soon as I say coefficient, oh, that constant is multiple of a variable. But as soon as I say only constant, okay, that particular number or real number which we are talking about, it's not a multiple of x, okay, or the variable. Here the variable is x. Now what we are going to do is on equating coefficient of x on both the sides. What is x coefficient? 3. What is here x coefficient? A is equal to 3. We wanted a and b value. Yes, we got. Let us suppose you could have, if we got the value, but for understanding sake, let us suppose now one extra thing I'm going to do. So what will happen if I could have taken constant to equate? So on equating constant, okay, this is R part, or so light it has become constant on both the sides. See carefully. What is the constant here? -1. And what's the constant here? Constant means not a multiple of the variable x. So here 2a plus b both are constant. Now see, we already know what is the value of b. It is -7. Substitute here. -1 is equal to 2a plus okay, b is -7, so -7 here. So if I transpose here, we are going to have -1 plus 7 is equal to 2a. So you will get here 6 is equal to 2a. 2 1s are 2 3s are. Therefore, a is equal to what? 3. That's what you got here. So what I'm trying to convince you and make you understand is, it's not that no, since I equated to x coefficient, you are also going to do, and you think that other if I equate I'll not get the answer, we will get the same. But it's always simple to get. So why to go for lengthy process? Okay. Now we have got both b value and a value. So put 4 and 5 the values in equation number 2 and integrate. With respect to x. Now here you see, when I'm going to integrate, see carefully, pay attention. Integral of 3x minus 1 divided by x I write properly, it's looking like a power. 3x minus 1. So here x plus 2 the whole square with respect to x is equal to integral of, what is a? 3. So 3 divided by x plus 2. Then b, what is b? -7. So put here -7 divided by x plus 2 the whole square. As you can see now we have decomposed nothing but one term we have split into 2, and very easily we can integrate from here. So actually speaking, here there is no much power for integration. Calculation you have to be perfect. Okay. Now again coming to this integration of 1 by x is, recall what is integration of 1 by x with respect to x? It is log of mod x plus c. And what is integration of 1 by x square? Because of this in itself, I said you to memorize the formula. I can avoid using x power n formula here. This will be minus 1 by x plus c. So see carefully here. 3 times of 3 is a scalar, take out. Let us go step by step. 1 x plus 2. I am going for difference rule as well as some means scalar rule. So here 3 have taken out. So 1 divided by x plus 2. Then here -7 out. 1 divided by x plus 2 the whole square with respect to x. So here we are going to have 3 times of, this will be of this form. Whatever term is there x, same term should be inside the log. So I'll get log of mod x plus 2. Then -7. Integration of 1 by x square is minus 1 by x. So whatever term is the same term but with the power 1. Here it is power 2, so it should be power 1. So again, see here only one more minus is there because of the formula. So minus 1 by x plus 2 plus c. So now from here final answer. And what is k log m? What is k log m? It is log m power k. So this 3 can go up, yeah, like this, no? Power of n. So this will be log of mod x plus 2 the whole cube minus minus plus 7 ones are 7 divided by x plus 2 plus c. That's it. Job done. Okay. I hope the thing is clear. Fine. Kindly make a note. Dear students, let us move on to type 3, where denominator with non-factorizable factor, nothing but we cannot factorize it. Serious, x square plus 1 is this term. This is the term which we can't factorize. So non-factorizable factor. This is one factor which we cannot further factorize. No, sir, I can factorize. Come on, just see x square plus 1. If it was minus 1, then a square minus b square is equal to a plus b into a minus b. Here, you cannot factorize. No, sir, I want to find the root and then I can factorize, because if x is equal to a comma b is the root, then x minus a into x minus b will be what? Factor. So using this logic, many might think of finding the root. Okay, find the root. And then we can think of factorizing, find the root, solve this. X square is equal to minus 1. X is equal to plus or minus root of minus 1. This is not a real number. We are dealing with real valued function, except chapter complex number in first PUC. Second PUC complete is what? Real numbers. Okay. Now, that's the reason we cannot factorize. Then how to solve? Coming to the solution part of this. And I have pointed which term because of this term. This system is already linear. No problem with that. Now coming to the solution of this. Forever. This mic is on. Yeah, on. So okay, let's proceed. So coming to the integrand, x divided by x square plus 1 into x minus 1 is equal to, this is a term which cannot be factorized. So we can write x square plus 1. So here it is linear. And it is quadratic, it is linear in numerator, and plus the factor is x minus 1, so it will be c, where a, b and c are the constant to be determined. So this is the extra thing which I just made you understand how to know it's not factorizable. In short, whenever you have got now, you can see x square plus 1. I think, but this also non-negative, this is always positive. This can never be equal to 0. The range of this is what? Closed interval 1 to infinity. Anyway, if you are still not able to do it, you can always go like this and understand. Now see carefully how we are going to proceed. Take the LCM, same old procedure, equation number 2. Now take the LCM. Again, I'm not able to take, no problem. Whatever is in the left hand side, that's your LCM. So we are going to have x square plus 1 into x minus 1. So this factor divided by, okay, first let us again write it here. Already. This factor divided by x square plus 1, both this will get cancelled. So I'll be having ax plus b into x minus 1 plus c divided by, this will get cancelled. So we are going to have x square plus 1. So very clearly you can see that this term will get cancelled on either side. Same procedure what we did in type 1, type 2. Only thing is the linear factor is there because it is quadratic here. So x is equal to ax plus b into x minus 1 plus c times of x square plus 1. This is our equation number 3. Now one by one equate the factor here. And I highlight this equation. Now let us equate the factor. If I put x minus 1 is equal to 0, this will give us x is equal to plus 1. Put in equation number 3. So we'll have 1 is equal to ax plus b into x minus 1 is already 0. No, sir, I want to substitute x value. 1 minus 1 is what? 0. Plus c times of x value is what? 1. This is 1. So 1 square plus 1. 0 and range is what? 0. This is 1. Then 1 is equal to c times of 1 square is 1. 1 plus 1 is what? 2. So from here, c is equal to 1 by 2 after cross multiplication. I hope till here it's clear. Nothing wrong, overriding. I am just avoiding that. So fourth equation we have got. Now I can't equate this one to 0. Even if I equate to 0, already we have seen we get imaginary. Then what to do? Whenever we are going to stuck like this, what we will do? We are going to expand this. First, consider equation number 3. So equation number 3 implies x is equal to ax plus b into x minus 1 plus c times of x square plus 1. Okay, now let us simplify. X is equal to ax into x will be ax square, ax into minus 1 will be minus ax, b into x is plus bx, plus into minus minus, b into 1 is b, plus c into x square is cx square, plus into plus plus c into 1 is c. Now let us rewrite. See carefully, we have degree 2, degree 1 and constant. So I will write x square. What is the coefficient of x square? A, and here c. I am rearranging them and also taking common. So a plus c. Then if I take x coefficient, here it is minus a and here it is plus b. Then plus c. Then here x. See, since I have got degree 2, degree 1 and the constant, so write this one in terms of degree 2, degree 1 and constant. Since there is no x square term, I can write this as 0 into x square, then plus x, then plus 0. Okay, so I hope the things are clear. Fine. Now equating on both the sides. So this equation, we are going to equate the coefficient on both the sides, because both sides we have polynomial and we have equal sign. So for two polynomials to be equal, their coefficient should be always equal. So on equating coefficient on both the sides. What is x square coefficient? On equating coefficient of x square on both the sides. What is x square coefficient? 0. And here what is that? A plus c. From here, solve for a, transpose this. A is equal to minus c. So a is equal to minus c, but from here a is equal to, what is c value? Half. So minus as it is, then half. This is our equation number 5. Now again equating coefficient of x on both the side. What is x coefficient here? 1. You can see, no, x multiplied is what? 1 is equal to, what is x multiplied here? Minus a plus b. But I know a value, substitute here. 1 is equal to minus, a value is minus half, plus b. Or I can say 1 minus minus is plus half plus b. So I can transpose this. B is equal to 1 minus half. What is 1 minus half? Half itself. So now I can say put 4, 5, 6 back in equation number 2 and integrate. Put equation number 4, 5 and 6 in 2 and integrate with respect to x. With respect to, let's write it clearly. I don't think, I have a doubt whether you can see or not if I write at the corner most, that too small. Now here integrating, see carefully, x divided by this entire thing I want to integrate, as well as I'm going to put the values of a, b, c which we have found here. Correct? No, oh, for here b, no, so this is b. Correct? Yeah. So x divided by x square plus 1 into x minus 1 is equal to, okay, with respect to x here. Next, a, what is a value? Minus half into x plus, what is b value? Plus half, divided by x square. You can see here, x square plus 1, then plus c. What is c value? Plus half. Then x minus 1 factor as it is. So just I have substituted. Now I have to integrate. Now when I am integrating, see carefully, I have got here x square plus 1 in denominator. I have got two terms here. I can split that. Always for this type 3, you will be getting this linear. No, you can split. And see, when you split, what happens? See, carefully, you see. Minus half x plus half. Okay. So this one, the denominator also I'm splitting here. Okay, with respect to x. And again, I'm applying some rule. I can also take this integration here separately. So just I have to integrate. First, kindly make a note. Okay, now let's complete the integration. So see here, minus half is a, see, I have to apply integral for both this. So minus, and I'm going to apply some rule because this is as a scalar rule. So minus half out, then integration of x divided by x square plus 1 with respect to x. Then again half plus half out, then integral of 1 divided by 1 plus x square plus 1 with respect to x. Then again half out, integral of 1 divided by x minus 1 with respect to x. This we see both are standard result, we can easily integrate, but here derivative of x square plus 1 is what? 2x. X is the numerator, so method of substitution. So only this particular integral we have to go for method of substitution. So I'll take, since I have taken 6 already, I'll take this as 7. Okay. Now differentiate. So first substitute, put x square plus 1 is equal to t. This is our equation number 8. So if I differentiate this with respect to x, derivative of x square will be 2x. I have applied some rule, plus derivative of 1 with respect to x will be 0 is equal to derivative of t with respect to x will be dt by dx. 2x plus 0 will be 2x is equal to derivative of t with respect to x. But you can see it is x into dx. So I will cross multiply, but half is means 2 is additional, so I will cross multiply. So I'll get x into dx is equal to half dt. This will be our equation number 9. Now put equation number 8 and 9 back in 7. Okay, put equation number 8 and 9 back in equation number 7. So our equation number, see, when I say equation number 7, only this part I'm talking about. I'm not talking about remaining. Okay, so we'll have minus half integral of x into dx. X into dx is half dt. Then x square plus 1. X square plus 1 we have taken as t. So substitute t. Okay, then plus here I will again delete, no problem. 1 divided by x square plus 1 with respect to x plus half integral of 1 divided by x minus 1 with respect to x. Let I erase this part. Now let us complete it. Only we have to integrate, nothing else. Now half into half will be 1 by 4 minus as it is. This is also from 1 by t, means 1 by x. What is integration of 1 by x? Recall, what is integration of 1 by x with respect to x? It is log of mod x plus c. So in place of x we have t. Integration of 1 by t with respect to t will be log of mod t plus half as it is. Integration of 1 by 1 plus x square is tan inverse x. I gave you list of formula to memorize. Then plus half of this is going with this formula again. Integration of 1 by x is log mod x plus c here. So this will be log of mod x minus 1 plus c. But what is t? Substitute back. What is t? X square plus 1. So you'll have minus 1 by 4 log of mod in place of t x square plus 1. Then plus half tan inverse x plus half log of mod of x minus 1. What is x? Sorry. There is no change here. Only as it is. No change here. Only for t we should substitute. Yes, everything is done. With this problem is completed. Kindly make a note. We'll go for improper rational function. Okay. Dear students, let us try to proceed with the next problem. See, there is no type 4. I have taken as type 4. As I said, as per my experience, student type 1, type 2, type 3, since we have given that heading and discussed, no, student remembers that, let's find the problem. Now, since we are not specifying this, no, so they never check whether it is a rational, means proper rational function or not. Directly they'll start solving by seeing the denominator. That's the reason I have taken during all my classes that improper rational function will take as type 4. So as soon as you see any problem, first we'll check whether it's a proper or not. If it's proper, depending on the denominator, linear, non-repeated, type 1, linear but repeated, type 2, type 3, non-factorizable, factorial if I've got. Depending on that, we are going to go ahead. Ultimately, this will reduce to one among the 3. Now see, degree of numerator is 3, denominator is 2, therefore it is improper rational function, type 4. Now let us try to take the integrand. X cube plus x plus 1 divided by x square minus 1. I want to divide, usual long division method. X square minus 1, this is the divisor, dividend is here. So x cube plus x plus 1. They give a like this, you write, or like this, both are what? Same. Okay. Now what you are going to do? You have to take such a quotient here that if I multiply with this, I should get the first term. For that, very simple. No, either you can have that mind calculation or x cube is there here. So x cube write down the leading power, and here also getting leading power you take down, and we should divide. So x square. If I divide x cube by x square, I get x. This x will be taken as the quotient. Now how you do your division? You are going to multiply divisor by quotient, correct? X square into x will be x cube, minus into plus will be minus, 1 into x is x. Then we will change the sign from minus to plus and from plus to minus. This is gone. Then x plus x will be 2x plus 1. You will continue this procedure till either the remainder is 0 or the remainder degree should be less than the divisor degree, less than, not even equal. Here the degree is 2 and here the degree is 1. So it is, this degree is lesser than this, so we have to stop. Now how we are going to write this? We are going to write quotient plus the remainder divided by the divisor. And if you just take the LCM and simplify, you get back this only. You can just see, take the LCM, you get denominator. X into x square will be x cube, x into minus 1 will be minus x, and this 2 term as it is. I have taken the LCM, correct? Now again I repeat, x square minus 1 and 1 LCM will be x square minus 1. So x square minus 1 into this will be the first 2 term. Then x square minus 1 divided by the LCM will be the same. So I'll get this. So you see x cube minus x plus 2x will be x. So I'll get this as x cube plus x and this plus 1 as it is, which is matching with the numerator here. Okay, fine. Now let us proceed. Now our major focus is this. So I'll take this as equation number 1. This I'll take as equation number 2. So I will consider equation number 2. In equation number 2, only this part separately. That is 2x plus 1 divided by x square minus 1. This I can write as, see this, I want to factorize this. X square minus 1 is same as x square minus 1 square. I can write this is from a square minus b square. What is a square minus b square? It is a plus b into a minus b. So in place of a we have x, in place of b we have 1. So we are going to have x plus 1 into x minus 1. Okay, so we have got the factor. So I can write here 2x plus 1 divided by x plus 1 into x minus 1. Now see denominator. First of all, is it proper rational function? Degree is here 1 and degree is here 2. So it's a proper rational function. Denominator is non-repeated linear factor. Therefore, because of the denominator, this is what? Type 1 noun. So let's proceed. For type 1, what we do? The linear factor we'll write, and then plus a here and plus b here. A and b are the constant to be determined. Left hand side no change. What is LCM of? And don't forget whether I write this or this, both are same. So I write this one. So we'll have x plus 1 into x minus 1. So LCM of this two will be x plus 1 into x minus 1. X plus 1 into x minus 1. If I divide this one by x plus 1, remaining is x minus 1. So a into x minus 1 plus b into x minus 1 is here. So x plus 1 into x minus 1 divided by x minus 1 will get what? X plus 1. Then 2x plus 1 divided by x plus 1 into x minus 1. Okay, now to simplify, same procedure from here. As soon as we find the value of this, we can substitute back here. So see here, okay, this other marker. See carefully, this will get cancelled. Then what is remaining? Mind it, there's a plus here. 1. Okay. So what is remaining now? We are going to have 2x plus 1 2x plus 1 is equal to a into x minus 1 plus b into x plus 1. And this is our equation number 3. We will take this one. But can I take a red marker also? Not there. Okay. Oh, yeah. Okay. I found at least green for a while. Yes, I found it. That will be better for observation point. Okay. Fine. Focus now. So see here. From here, again, we are going to equate each of the factor and get the value. So equation number 3 then. So this is our equation number 4. But I highlight that. Visible, no? Yeah. So now, put this first factor I will equate to 0. Nothing but x is equal to 1 in equation number 4. So you are going to have 2 into 1 plus 1 is equal to a times of x minus 1 is 0 plus b times of, in place of x we have 1. So put here 1 plus 1. A into 0 is 0. 2 ones are 2. 2 plus 1 is equal to b times of 1 plus 1 is what? 2. 2 plus 1 is 3. Cross multiply. So 3 by 2 is equal to b. Okay, this is our equation number 5. Again equate this one to 0. X plus 1 is equal to 0. X plus 1 is equal to 0 will give us x is equal to minus 1. Again, if I put in equation number 4, we are going to have 2x, okay, in place of x minus 1. So 2 times of minus 1 plus 1 is equal to a times of, in place of x minus 1. So minus 1 plus b times of x plus 1. What is x plus 1 value here? 0. Or even if you put x is equal to minus 1 plus 1 will dot 0 only. B into 0 is 0. So 2 into minus 1 is minus 2 plus 1 is equal to a times of minus 1 will be minus 2. So from here minus 2 plus 1 will be minus 1 is equal to minus 2a. Negative will get cancelled. So a is equal to 1 by 2. Okay. And this is our equation number 6. So put the value 3 means I mean to say 5 and 6 in equation number 3. First let us substitute. So put equation number 5 and 6 in equation number 3. Okay. When I do so, you see we can do one more thing now. In place of substituting here, then see this term, nothing but this is here. So again I should substitute here. Than saying that, what we can say is put the value. I think this is better. Let us go the same way. So what are we going to have? 2x plus 1 divided by x plus 1 into x minus 1 is equal to a. What is a value? Half times of x plus 1. Then b. What is b value? 3 by 2. 3 by 2. Then x minus 1. Let us substitute in. We got this. Now see, we wanted to integrate this and we have got this particular step. So in this step we are going to substitute and also integrate. So I'll say put this one in equation number 2 and integrate with respect to x. First make a note of this. Now dear students, I'm going to integrate this because I said integrate with respect to x. So from here we are continuing. So I've just written the step as it is. X cube plus x plus 1 divided by x square minus 1 with respect to x is equal to integration of x plus this term is nothing but this, and after simplification we have got this. Let's substitute. What we have got, half into x plus 1 then plus 3 by 2 x minus 1 with respect to x. Now one by one we have to integrate. See this one, integration of x power n with respect to x is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1, and this one is of the form integration of 1 by x with respect to x is log of mod x plus c. So see carefully from here, this one power is 1 here, so in place of n we have 1. Integration of x power 1, 1 plus 1 divided by 1 plus 1, no, so n is 1, 1 plus 1 is 2, again 1 plus 1 is 2, plus half of 1 by x plus 1. What is integration of 1 by x? Log mod x. So this will be log of mod of x plus 1. You can see, no, power of x is 1 here and here also 1. So it's a linear and it's also linear factor. So whatever is there, same thing here. Similarly here, plus 3 by 2 log of mod x minus 1 plus c. This will be the answer. So we have finished all the types. Kindly make a note. Okay. Dear students, now let us proceed with the last method of integration, that is integration by parts. Okay, already root quadratic is already done at the beginning. I was just combined with the 7.4, that is 1 by quadratic and 1 by root quadratic. Now, how to know? First of all, I have to apply parts. We should have product of functions, that two dissimilar function, not similar, okay, dissimilar, nothing but different. Now, how to recognize which is first function, which is second function? For that, we are going to use I late. Let's specify here I late. Very simple, no? I am late. I am late. What I stand for? Inverse trigonometric function. As I can recall, I stand for inverse. Recording, no? Yeah. I stand for inverse trigonometric function, like sine inverse, example, then sine inverse of x, tan inverse of x, and so on, etc. L stand for logarithmic function. Logarithmic function. A stand for algebraic function. T stand for trigonometric function. E stand for exponential function. Let us recall the example also for this. Coming to exponential function, the example can be a power x, e power x, etc. Trigonometric function, example, all the 6 trigonometric function, sine, cos, tan, cosecant, secant, so this is sine x, cos x, etc. All the 6. Algebraic can be x square, x power 3, example, and for this the example is what? Log function, log x. Whenever you have got log, it's a logarithmic function. Now you see this, you have to identify x is which function, x is which function. X is algebraic function. This is inverse trigonometric function. So in the word I late, see who is coming first. First, see, I-L-A-T-E. I is coming first, then followed by A. So I is coming first. So this is the first function and this is the second function. So what is the formula? Very simple. Recall integration by parts. integration of f of x into g of x with respect to x. I ask you to remember as first function and second function to be given. So after selection of first and second function, how to remember the formula? Keep the first function as it is, then integrate the second function minus double integral of second function, then derivative of the first function. Okay, so keep the first function as it is, integration of second function minus double integral of second function, derivative of first function. Actually speaking, this should come first and this should come second, is only this term, but both are same. Okay, no problem. Now how to remember, sir? Second function I should integrate but not the first function, and first function should be differentiated. Simple. In first PUC, what you learn first? Integration or differentiation. First you learn differentiation in first PUC, then in second PUC you learn integration. So always the first function is differentiated and second function is integrated. Simple as that. Now see carefully. Now applying the formula, keep the first function as it is, that is tan inverse x, integration of second function minus double integral of second function, derivative of first function with respect to x. What is integration of x? Recall, what is integration of x power n with respect to x? It is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. So in place of n we have 1. So apply 1 plus 1 by 1 plus 1. So I'll get x square by 2. 1 plus 1 is 2 minus integral of, only we are going to integrate this. Integration of 1 with respect to x will be x square by 2. One thing you can see in the formula also, no? This part, you see, this part. Whatever is there, the same thing again, correct? No? So whatever we got the answer, same we are going to have here also. Okay. Derivative of tan inverse x is 1 divided by 1 plus x square dx as it is. Now see carefully. I will just write x square at the left of inverse trigonometric function. X square by 2 here, tan inverse x. Then half out. You cannot take variable out. Okay. X square into 1 is x square. Now see carefully this step. See carefully. You cannot go for method of substitution, because if you differentiate, derivative should be in the question. Derivative of x square is 2x, but we have got x square, so you cannot think of what method of substitution. But whenever you see degree is same, denominator degree and numerator degree both are same, then you have to regenerate the denominator in numerator. Here you see x square, x square. Here what do we have? 1. So what we are going to do is add and subtract 1 here. So add and subtract 1 by only 1, because we have 1 here. If you have 7, add and subtract 7. So add, this is one color. Add and subtract 1. So see carefully what's happening. We are going to have x square by 2 tan inverse x minus half. So add 1, subtract 1, divided by 1 plus x square dx. Now here, see carefully, this is same term here. And now see carefully, we can think of writing from here. Let us complete here. See carefully, x square by 2 tan inverse x, then minus half. Now this term says 1 plus x square only, but this also and this also. So split them. So integral of 1 plus x square divided by 1 plus x square minus 1 by 1 plus x square with respect to x. I have given a bracket because minus half is multiple to this entire. So since I have splitted, it means whatever the answer I have got, whatever the answer we have got, for that minus half should be multiplied. And you can see here 1 plus x square by 1 plus x square will get cancelled. That's the advantage, that whenever you see degrees are same, try to generate the denominator and numerator so that you can cancel like this and easily you can integrate now. So just see carefully. Here we have 1 because of cancellation. So I've got x square by 2 tan inverse x minus half, integration of 1 minus 1 by 1 plus x square with respect to x. Now x square by 2 tan inverse x minus half integration of 1 with respect to x is x minus integration of 1 by 1 plus x square will be tan inverse x plus c. So finally, let us write with multiplication of half, or we can write it as it is, no problem. Even you can stop the answer here, or we can multiply better. So what do we get? X square by 2 tan inverse x minus 1 x. 1 into x will be x, so minus x by 2. Minus to minus is plus. Half into tan inverse x will be half here. Tan inverse x plus c. So this will be the answer. Okay, kindly make a note. A 3-marker question from model question paper number 2. Fine. Dear students, now let us move on to the next problem. If you just see integration of x sin inverse x divided by root of 1 minus x square. See, repeatedly I am saying that this type of heading will not be given, and you can see in exam this question paper also same thing they are given, exactly whatever they have given, same thing I copied from model question paper number 1 from KSEAB, 2-marker question. Now, how are we going to know? I have to apply. First of all, we will not come to know because here it is 1, 2, 3 terms are there. But see carefully, what is sine inverse x derivative? It is 1 by root of 1 minus x square. So 1 by root of 1 minus x square is there. So method of substitution. So equation number 1. So method of substitution. So put sine inverse x is equal to t. So presently we are not going for method integration by parts. Since the derivative of sine inverse is there in the question, so we are going for method of substitution. So differentiate this with respect to x. So this is x minded. This will be 1 divided by root of 1 minus x square is equal to dt by dx. I can cross multiply 1 into dx is dx divided by root of 1 minus x square is equal to dt, equation number 3. Okay. Now put 2 and 3 back in 1. If you put equation number 2 and 3 back in 1, we are going to have, see carefully, sine inverse of x is t. So I wrote t. dx by root of 1 minus x square. See carefully, this term is t. I wrote t. Then dx by this, okay, I'm highlighting, is what? dt. So I wrote dt. Only what is not taken? X. So from here, take sine on both the side. By I want x value. So x is equal to sine t. So in place of x, sine t. Now see what you have got. Product of 2 terms. So I have to apply by parts. Let us copy again here. So what do we have? Integration of sine t into t with respect to t. So see, it can't be always no, we should have variable x. It can be some other variable t also. So I want to integrate with respect to t. I have got product of 2 terms. So think as sin x and x, correct? No. So this is what? Trigonometric function. This is what? Algebraic function. In the word isolate, who comes first? See, first comes a, then comes t. A comes first, then t. You should go always left to right, left to right. So a comes first, then t. So I have to apply isolate. It has integral by parts formula. What it says, I can erase this part now. We need space to complete the problem. See carefully. Moving on to integration by parts formula. Integration of f of x into g of x with respect to x is, keep the, this is our first function and this is our second function. Keep the first function as it is. Integrate the second function minus double integral of second function into derivative of first function. Now let us start. Keep the first function as it is, integrate the second function, double integral of second function, derivative of first function. Correct na? Now let us proceed. Keep the first function as it is, nothing but t you keep as it is. Integration of second function, nothing but sine t with respect to t minus double integral of, again, second function is sine t with respect to t. Then derivative of first function, nothing but t with respect to t. Now What is integration of sine x? It is minus cos x. So sine t will be what? Minus cos t. Then minus again what is integration of sine t with respect to t? It will be minus cos t. What is derivative of t with respect to 1 itself? I repeat, derivative of t with respect to t is 1. Okay, now minus is plus, and here plus into minus is minus p cos t, minus is plus, integration of cos t into 1 is cos t. So what is integration of cos sine? So we have got the integration done. But be careful, our question was in terms of x, so our answer should be also in terms of x. So we are going to resubstitute. See carefully one by one. See here, sine inverse of x. I'll write again here. Sine inverse of x we have taken as t, and from here x is equal to sine t. So in place of t, in place of this t, it is sine inverse x. Here we have cos t, no? Come on, take a right angle triangle. Take up a right angle triangle. And angle is here, t. And is it not x is same as what? X by 1. Why am I taking? Because I want cos value, okay? So, what is sine definition? Opposite by hypotenuse. So, t is here. So, opposite is x and hypotenuse is 1. So, using Pythagoras theorem, root of 1 minus x square we are going to have. So, cos will be adjacent by hypotenuse. Adjacent is root of 1 minus x square divided by 1. Plus, what is sine t? Sine t is x by 1, nothing but x itself, plus c. Or my final answer, minus sine inverse x, root of 1 minus x square by 1 is same thing, plus x plus c. This will be our final answer. I hope this is clear. Kindly make a note. Okay, yes, dear students, let us move on to the next problem, the last problem under indefinite integral. Yeah, recording. Indefinite integral. Next part will be on definite integrals. Okay. Now you see this. How are we going to know that this will be, okay, then you have 3 marker question. That we have to apply some other formula. I think this formula is not given list of formulae when it was given. Okay. Now just see this carefully. We have one formula, integral of e power x, f of x plus f dash of x with respect to x. See carefully, e power x is multiple of addition of the function and its derivative. Oh, what is other marker? It's here. So, e power x is multiple of addition of f of x and its derivative. If it is so, then we will get e power x into f of x plus c. I am not gone for the derivation for this. But here, whenever you see e power x, now once you think in this angle, surely you cannot apply by parts because 1, 2, 3 terms are there. Now, how to proceed? See carefully. If you see the denominator, you have got x minus 1 and here we have x minus 3. So, try to generate the denominator and numerator. Here we have x minus 1 as the factor, here we have x minus 3. So can't we write this one as x minus 1 minus 2 divided by x minus 1 the whole cube e power x dx. Now see, this is matching with the denominator. So now I can split this one as x minus 1 divided by x minus 1 the whole cube minus 2 divided by x minus 1 the whole cube e power x dx. Now see carefully, this term and denominator both are same. So one term will get cancelled, get square here, power 2. So we are going to have 1 divided by x minus 1 the whole square minus 2 divided by x minus 1 the whole cube into e power x with respect to x. Now having this, see carefully. Now you can see e power x, and here looks difference of two terms. But first let us try to take f and find the derivative. Then we will come to know it is going to exactly match with this. F of x is this, is equal to 1 divided by x minus 1 the whole square. See, to differentiate this, because I want derivative, don't apply quotient rule. It's waste of time. Here we can just say that this is same as x minus 1 whole power minus 2. So, and you can apply the formula derivative of x power n with respect to x is n into x power n minus 1. So, when I'm going to differentiate this with respect to x, in place of n we have minus 2. So, I'll get minus 2 into, now see carefully, x, yeah, x. So, in place of x we have an x minus 1, n minus 1, n is minus 2, minus 2 minus 1 nothing but minus 3. So, we are going to have minus 2 into x minus 1 whole power minus 3, or minus 2 divided by x minus 1 whole power 3. This is our f dash. This is our f dash. But I change the marker. Yeah, see here. This is our f dash. Correct now? Now see carefully, that is there here. So if I take this as equation number 1, expression 1, this is our expression number 2, and this is our expression number 3. So put 2 and 3 back in 1. When we are going to put 2 and 3 back in 1, our equation number 1 will become integral of 1 divided by x minus 1 the whole square. I think, but here f of x it is. Then minus 2 by x minus 1 the whole cube. Minus 2 by x minus 1 the whole cube is f dash. See, be careful. Minus 2, yeah, with minus. Here the sign of f dash is plus because there is no sign, so f dash. Then e power x. Now see, this is exactly resembling this formula. Yeah, e power x is the left or right, there is no problem. A into b same as a b into a, and we are going to have a e power x into f of x. Okay, e power x into what is f of x? Yeah, here it is. 1 divided by x minus 1 the whole square plus c. E power x into 1 is e power x divided by x minus 1 the whole square plus c. Yes, we have got the result. Kindly make a the solution. Kindly make a note of this. Okay, dear students, with this we come to an end on indefinite integral. All the problems from model question papers I have solved already. Part 1 is uploaded. This is part 2. So make sure go through well and write in practice. We're going to see if you are understanding part 1 and part 2. The definite integral will not be so big thing to understand. It will be easier only. And there we are going to have 6 marker properties problem, and I'm also going to discuss a shortcut method to identify odd and even for 1 marker we are getting. Okay, so make sure study well, give you 100%. Okay, days are just coming closer there. Okay, all the very best, do well, and thank you for your overwhelming support. And lastly, do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you.